to Concepts 1.0. Thank you for joining me on measurements for IGCSE 0625 course. So we are going to look forward into displacement method again, the point from where we left off in the previous lesson. So we'll be moving on from the same point. Displacement method, as we have discussed so far, like it is being used for those things which are too small to be measured by an exact instrument, or for such things which do not have a definite shape. So for such objects, for example, those which are known to be as irregular shape objects, for finding a volume of such objects, there is a method which is known as displacement method. And today we are now going to discuss how to find a volume of an irregular shape object. The shape which you can see here is known as irregular shape. For example, a shape of a stone, a shape of anything which we cannot identify to be as a definite shape. For example, we have such shapes which are known as square, triangle, circle. These are such shapes which we knew them from many years ago, and they have some certain formulas for finding their areas and volume. For example, for finding a volume of a square, what we have a formula is just length times width times its height. This is how to find a volume of a definite shape. Similarly, we have different other formulas for circle, for sphere, for finding their volumes. But what if we have to find a volume of an non-definite or irregular shape object? So this is a method in which you can find a cylindrical tube for finding the volume. So you can say for volume cylinder. The process goes by a step-by-step process in which you have to take a volume cylinder first. Take a volume cylinder which has some measurements being marked on its sides. So these are measurements, starting point, and this one is the ending point. Okay. Second, pour some water to such a level that the object which you want to measure is going to be dipped completely inside the water. For now, you don't have to dip the object. Just take a cylinder and pour some water. Third step, note down the reading of the water. Note down the reading of the water. As in this case, we can see the reading is just a little bit above 50 centimeter cubic mark. So we call it to be as 60 centimeter cubic. So we note down our reading without the object to be as x1 to be as 60 centimeter cubic. Now take the object for which you want to measure the volume. This is a piece of a stone. So we say like a piece of stone has been taken for knowing its volume. Now your fourth point would be, what we have to do is just put the stone or object which you want to find the volume for into the volume cylinder. Now after pouring this thing, you can see there would be an increase in this water level. This increase in water level is basically because of what? Because of the extra volume we put into the cylinder. And that extra volume is for stone basically. So now when we put the stone, the volume goes and you have to take the reading again. So your step number 5 would be read the reading again. And in this case, you can see the reading is just above 60 centimeter cubic. So we mark it to be as 70 centimeter cubic. So our reading, we mark and we label this reading to be as x2, which is coming up to be 70 centimeter cubic. Now you have two readings in front of you. One is for empty cylinder without any object, just water inside it. The second reading is with a stone inside it, or with the object which you want to find the volume for. So now we had to check the difference between these two values, which is your delta x value. So which comes up to be x2 minus x1. And when we calculate the difference, it gives you a difference of 70 centimeter cubic minus 60 centimeter cubic. Your value comes up to be around 10 centimeter cubic. That is the difference between these two values. And this difference is basically volume of your stone, volume of any object which you are measuring. So volume is going to be 10 centimeter cubic for stone. This is the method for finding the volume of an irregular shape object with the help of a displacement method. So now moving on to the other aspects of this chapter, chapter number 1 for measurements. In this chapter regarding volume, as we have discussed volume, the other thing which we want to discuss and put light some on this is density. What is density? Density is a property of an object, or you can say property of a mass where it is being more concentrated. Okay, in terms of or you can say in scientific terms, we call it to be as a ratio of mass to volume, or you can say a ratio of mass per unit volume, like how much mass any object is containing in 1 centimeter cubic of a volume, or in any specified amount of volume. So if we are specifying the amount of volume for any object, for example, if I'm taking a sack of stones and I'm saying like this sack is going to be of 1 centimeter cubic, or one, whatever the reading would be, 1 meter cubic. And in that 1 meter cubic, if, for example, I'm going to take the example of this sack. So if I say I contain sack of 1 meter cubic, okay. So I would be taking one sack. Its volume is 1 meter cubic. The other sack with the same amount of volume, 1 meter cubic, its volume is. Now, how to identify the density of these two things is when we put some mass inside this sack. So now I'm going to put some mass. For example, I'm going to put 7 stones inside it. 7 stones of 1 kg each. So my 7 stones are going to be here. In this, I'm going to increase the density. How should I increase the density? By putting more stones. So I'm going to put 14 stones of 1 kilogram each. So my density would be, in this scenario, it has been increased to the double of the first sack. This is sack number 1. This is sack number 2. And you can see and check, like in first sack, the stones are far apart. There are much more empty spaces. So my mass is not too much concentrated. My mass is, you can say it's diluted. Diluted with what? Diluted with air. There is some air spaces, there is some stones, then we had a lot of air space. And so stones are far apart. So stones have a multiple space to move around. So my most of the sack is empty. So its density, if you want to go with specific terms, if you want to go with scientific terms, terminologies, the density would be D is equals to mass over volume. This D is basically representing density, though its symbol is not D. Its symbol is rho. That is a Greek letter, which is known as rho, is representing density here. So if you want to represent density, it gives you density is equals to mass over volume. So here, in case of sac number 1, our mass is 7 kgs and volume is 1 meter cubic. So your density becomes 7 kilogram per meter cubic. That is your density in terms of exact numbers, what we are discussing here. So you can see the number is quite less according to the volume given to us, which is 1 meter cubic. So means stones have a lot of space to move around. Coming towards sac number 2, when we go with scientific terminologies, so your rho is equals to mass over volume again, which gives you mass of 14 kilograms over same volume of 1 meter cubic, which means your density becomes 14 kilogram per meter cubic. So now the density is doubled. So when you increase the density and make it twice of the first one, so you can see stones doesn't have enough spaces. So here you can see the space is limited. Here is a multiple amount of space provided in this side, in between the molecules. But here you can see in between the molecules the space is less. Here is only the amount of space you have with you is this space. No extra amount of space is provided to the stones because of doubling the density, doubling the mass. So the more the mass of any object in specified, or you can say in constant volume, the density would be increased. This is the concept of density. Density is a property of any object in which the mass has been doubled. So that is what we call it here as density. For finding or for memorizing the formula for density, there is one more method or technique which students can find easily is this triangle. Make a triangular shape and put a T inside it. Now in this T, density has been mentioned here, which is known as D, okay, and mass over volume. This is the best example, or this is the best method of memorizing your density formula. Sometimes people forget, or students forget this formula, so don't worry about forgetting the formula. Just put and memorize this triangular shape so you can find density formula, mass formula, or volume formula in terms of any question when they're asking for any particular subject. For example, if they're asking for density, so you can memorize D is equals to mass upon volume, because mass is on the upper side and volume is on the lower side, so we put mass over volume. In another case, for example, they're asking for volume, so remember volume here, and in front of volume you can see mass over density, because mass on the upper side and density on the lower side, so your formula becomes mass upon density. Similarly, if someone asks you about mass, so mass is on the upper side, so you put equals and see on the other side of the mass, density and volume are in front of each other, so you put density times volume. Whereas these all three formulas can be deduced from this simple and straight triangle. So this is what density is all about, and this is almost the end of your chapter as well. So please notify me any topic which you are not clear with in this whole IGCSE curriculum. So I'll be looking forward from your comments and suggestions for different topics. See you in the next video with much more topics. Have a nice day. Bye bye.